Hey everyone! You ever open a math book and just feel lost? Like you're trying to read a totally different language? Well, you're not wrong. In fact, that's exactly what we're going to do today. We're going to treat algebra as a new language. And trust me, by the end of this, you'll be on your way to speaking it fluently.
So, let's just ask it straight up. Is algebra a foreign language? I mean, think about it. It's got all these weird symbols, its own grammar, its own set of rules. It sure looks like one, right?
The answer? Yup, it totally is. And you know what the best part is? You're about to become fluent. We're going to give you all the tools you need to translate regular old English into the super clear, super powerful language of algebra. So, let's dive in.
Okay, so every language has to start with its alphabet, right? You know, the basic building blocks. Well, in algebra, our alphabet is made of two main things. Numbers, which, hey, you already know those, and this other thing called variables.
So, what in the world is a variable? Honestly, it's pretty simple. It's just a letter, like X, Y, or N, and it's basically a placeholder for a number we don't know yet. I like to think of it as a blank space in a sentence, just waiting to be filled in. It's the mystery we're trying to solve. And that's what makes them so powerful. They let us write rules that work for any number, not just one.
All right, we've got our alphabet. Now what? Well, we need a dictionary, of course. This next part is basically our translation guide. It's how we turn key English words directly into math operations. Seriously, this is where the magic happens.
Okay, check this out. This table right here, it's like our Rosetta Stone for algebra. It shows the 4 big foundational key words you have to know. See, sum just means add. Difference means subtract. Product, that's multiply. And quotient means divide. This table is basically your ultimate cheat sheet for turning English into math.
But just like in English, there are a bunch of ways to say the same thing. So while sum is the main keyword for addition, you'll also see stuff like increased by or more than. Whenever you spot one of those, your brain should just go, aha, that's a plus sign.
And it's the exact same deal for subtraction. Difference is the fancy official word, but you'll also see things like minus, decreased by, or fewer than. They all scream the same thing. We're taking something away. It's subtraction.
Now for multiplication. Here's a sneaky one you got to watch out for. The word of. It's tiny, but it's super important. It almost always means you need to multiply. Like if I say half of a number. And then you have the easy ones, right? Twice or double are just quick and easy shortcuts for saying times 2.
And last but not least, division. The big keyword is quotient, but the one you'll probably see most in real life is per. Think about it. Miles per hour, dollars per item. Whenever you see that word per, that's your cue. It's a signal for division.
Okay, deep breath. We have our alphabet, variables. We have our dictionary, the keywords. Now it's time to put it all together. We're going to stop translating single words and start building full-on mathematical sentences. In algebra, we call these expressions.
Let's start with a nice, easy one. How would we go about translating this phrase right here? The product of 5 and a number.
Don't overthink it. We can break it down into a simple 3-step process. Step 1, spot the keyword. Here, it's product, and we know that means multiply. Step 2, find the pieces. We've got the number 5 and a number. That's our mystery variable, so let's just call it X. And finally, step 3, we build it.
And voila, there it is, our translation. That whole phrase, the product of 5 and a number, just becomes this nice, clean, simple expression, 5x. That's literally it. You just spoke your first sentence in algebra. How cool is that?
All right, you ready to level up a little? Let's try something a bit trickier. This one has 2 operations tucked inside. 3 more than twice a number. How do we even start with that?
Okay, here's the secret trick for these longer ones. You work from the inside out. So let's find the main part of the phrase first. Twice a number. We know from our keyword dictionary that means 2 times x, or just 2x. Easy enough. Now we just add on the other part. 3 more than. Well, that just means we're going to add 3 to what we already figured out.
And boom, there it is, 2x plus 3. See how that works? By just breaking the sentence down into smaller, bite-sized pieces and translating them one at a time, you can tackle even the really complex phrases. No problem.
Okay, you've totally got the basics down. So now, let's talk about a few pro tips to really make you fluent. We'll look at some common grammar rules and little traps to avoid. And then, we'll see where this stuff actually shows up in the real world.
So here's a really important grammar rule in algebra. The number part, that's got a fancy name, the coefficient. It always goes in front of the variable. So we always write 5x, never ever x5. It's a small thing, I know, but it's just how the language is spoken.
And here's another pro tip that makes algebra look so, well, clean. When you see a number and a variable just sitting right next to each other, like in 3x, it means they're being multiplied. The multiplication sign is basically invisible. It's just implied. It's a great little shortcut.
So why does any of this even matter? Because this language, algebra, is literally everywhere. You're already using it, and you probably don't even realize it. For real, think about going shopping. You see a price tag that says, $5 per item. Guess what? You're reading algebra.
That simple, everyday phrase translates directly into this really useful little formula. The total cost equals 5n, where n is just the number of items you're going to buy. See, you've been speaking algebra your whole life to figure out how much you're spending.
So there you have it. We've given you the alphabet, a dictionary, and some basic grammar. You now have the key to a whole new language, and it's the language of problem solving. So the only real question left is, now that you have the key, what kind of problems are you going to translate and solve?